Hi, welcome to part 2. So I have found that the charge over this whole big equivalent capacitor is, or charge stored on the whole big equivalent capacitor is 154.3 microcoulombs. Now, that means I've got, if I look at this, that's the charge, I've got two capacitors in series. C5 and the equivalent of 1, 2, 3, and 4. So, I know, the charge stored on C5 has to be equal to 154 microcoulombs. I also know that Q1 plus Q2, Q12, the charge on the equivalent capacitor 1, 2, plus the charge on the equivalent capacitor 3, 4, those two together have to sum to be 154 microcoulombs. But because I know C5 and the charge on capacitor 5, I know that the electric potential over thing 5 is equal to 154.3 microcoulombs divided by what the heck was C5 again? 10. I don't have the ability now to go back, so I'm going to have to work with my memory here. 10 microfarads, or the electric potential over capacitor 5 is 15.4 volts. Now, that means that the change in electric potential over the equivalent capacitance of 1, 2 has to be 24 volts, the whole thing, I forgot to take note of that, so there's going to be a bit of rounding error in here. 8.6 volts. There's rounding error in here. I'm not going to stop and fix that now, because I erased over some stuff. Or actually, right, whoops. Didn't see I had that. Let's call that 8.57 volts. Now, 3 and 4 are parallel. So I also know the change in potential over capacitor 3 has to be the same as the change in potential over capacitor 4 is, now in this case, I can go to the proper number, I lose the sig fig here, track it, ask me about it if you don't see where that's going to, and find out that the change in electric potential over thing 3 and thing 4 is 8.6 volts. And I can find then from this equation the charge on each one of those capacitors. Let's see if I remember correctly. 3, 6, 4 and 12, I believe. I hope so. Probably should have written that down more carefully. If I do this as, let's see, assuming 3, 6, I think 4 and 12, then the charge stored on capacitor C3 is 34 microcoulombs. the charge stored on Q4 is 103 microcoulombs, and the charge stored on both thing 1 and thing 2 has to be equal to what's left. So I've got 154 microcoulombs stored on this whole equivalency, minus 34 microcoulombs, minus 103 microcoulombs, means that both of these have a charge of 17 microcoulombs stored on them. Now, I can then find the change in potential, and that should work out if I'm remembering this correctly. So the change in potential is the charge divided by C1. So 17 divided by 3 is 5.7 volts. And then the charge over thing 2 is 2.8 volts. And within rounding error, then, the change in potential over thing 1 and 2 is equal to the change in potential over both thing 3 and thing 4. So, all right. I hope that serves as a useful example.